several years of determined development, the United States has finally unveiled its quiet supersonic aircraft. The X-59 is said to be the very first quiet supersonic aircraft, and this achievement has reignited the hope for commercial supersonic flights. With its advanced and powerful engines and designs, the U.S. has once again pushed the boundaries of technology and shocked the world in the process. What effect would the X-59 supersonic have in the world of aviation? What are the capabilities of this new supersonic aircraft? Join us as we explore the features of the United States Air Force stealth X-59 Megasonic aircraft. Speed has always been an important factor, always deeply considered whenever creating a military weapon. However, the phenomenon known as sonic boom has long been a significant drawback for supersonic aircrafts. This phenomenon occurs when an aircraft exceeds the speed of sound. This is because compressed air molecules around it create shock waves that merge into a loud, disruptive noise known as a sonic boom that is quite audible on the ground. This noise has historically hindered the commercial feasibility of supersonic travel over land. Many of the issues associated with supersonic flight can be traced back to the Concorde, the renowned supersonic passenger jet that was developed by France and the United Kingdom and has the capability of flying from New York to London in just 3.5 hours. When the Concorde first took flight in 1969, it captivated people with the promise of incredibly fast air travel. However, the excitement reduced when they experienced the noise it generated. As the Concorde broke the sound barrier, it produced a thunderous boom that sounded like a bomb explosion, shattering windows and causing doors to tremble. Its powerful engines caused a loud sonic boom with a pressure of about 2.2 pounds per square foot. Because of this noise, many countries banned supersonic flights over land or populated areas. The FAA also restricts supersonic flights over land, except in certain military zones. When planes started flying faster than the speed of sound over the U.S., the noise became such a problem that Congress banned civilian supersonic flights over land in 1971. This ban was officially put into effect in 1973 and was later adopted worldwide. The decision was heavily influenced by surveys in cities where supersonic military jets flew overhead, with many people complaining about the noise and their rattling windows. This ban stopped the growth of the transportation industry for many years. Nevertheless, in 2016, NASA asked Lockheed Martin and a host of other companies to submit a proposal for a test aircraft that could demonstrate that supersonic flight over land was safe and as silent as regular subsonic airliners. The target was to make a plane with a boom of just 75 perceived loudness in decibels, a volume unit that measures how people perceive sound as opposed to the actual decibel produced by the sonic booms. A 75 perceived loudness is the equivalent of hearing a dishwasher for less than a second. For comparison, the Concorde's perceived loudness was 105, or as loud as listening to a chainsaw at full power. In 2018, NASA awarded Lockheed Martin a $247.5 million contract to build and deliver the low-boom X-plane. The plane received its official nickname, the X-59, in a program called QuestST, or Quiet Supersonic Technology, from the U.S. Air Force in June 2018. But the company still had a long road ahead of it to develop a truly quiet supersonic jet. By November 2018, Lockheed Martin had initiated the machining of the X-59's first part in Palmdale, California. Major structural components were assembled by May 2019. This aircraft was initially set to start flight tests in 2021, but it encountered some delays. However, after the stumbling block, it is now scheduled to be delivered to NASA for testing in 2024. The plane is expected to fly at Mach 1.42 and at an altitude of 55,000 feet, producing a low noise level of 75 effective perceived noise decibels to test the feasibility of quiet supersonic travel. However, there are plans to undergo various tests before moving to NASA's Armstrong Flight Research Center. In late 2014, it will fly over 6 different United States neighborhoods to gauge public reactions. The goal is to make supersonic flight over land acceptable and potentially change current regulations. Recently, NASA installed a powerful engine on the X-59 in early 2024. This step shows that the aircraft would be ready quite sooner than later. The General Electric F414GE100 engine, which powers one of the most powerful fighter jets in the U.S. Navy, F/A-18 Super Hornet, found its place in this supersonic aircraft. However, the engine is at the top rather than the bottom of the plane to keep a smooth lower profile that prevents shock waves from reaching the ground. The aircraft has since undergone a battery of tests, from weight checks and fuel system evaluations to ground vibration assessments. Remarkably, the X-59 weighed in below the anticipated weight, which is quite a rare achievement in aircraft development that surprised the entire team. The plane, which is about 100 feet long and is built with a sleek design to reduce sonic booms, is expected to be much quieter than the Concorde, aiming for only 75 decibels of noise at supersonic speeds. However, this supersonic aircraft is simply a technology demonstrator, and future passenger supersonic planes may look different, but could use some of its design ideas. The X-59 has been rolled out in front of cameras once before, in August 2023, but that was before the jet had gone into the paint barn for its final red, white, and blue paint job, or livery. Finally, NASA and Lockheed Martin formally debuted the agency's X-59 quiet supersonic aircraft on Friday, January 12th. According to NASA Deputy Administrator Pam Melroy, it is a major accomplishment made possible only through the hard work and ingenuity from NASA and the entire X-59's team. In just a few short years, they've gone from an ambitious concept to reality. He points out that the supersonic aircraft will help change the way we travel, bringing us closer together in much less time. Following the unveiling, Lockheed Martin emphasized that the supersonic marvel opens doors to various applications, including rapid medical response, shorter shipping times, and of course, faster travel. When the curtain finally fell to reveal the X-59, the assembled crowd applauded and held their mobile phones aloft to capture photos of the new jet, shining red and blue under stage lights. During that rollout, the striking and unique geometry of the aircraft was on full display. The aircraft features a sharp, elongated, beak-like nose section that measures 38 feet in length. The nose section will help shape the shock waves the aircraft produces during flight. NASA said in a 2021 statement that nose also means pilots flying the X-59 can't see out of the jet's forward windscreen because it doesn't have one. Instead, pilots use what NASA calls the External Vision System, or XVS, to see in front of the aircraft. This system uses a forward-facing camera, a cockpit-mounted display screen, and custom image processing software to create an augmented reality view of the pilot's forward line of sight, along with graphical flight data overlays. As exciting as the unveiling is, it's only the beginning for the supersonic marvel. According to Catherine Baham, manager of NASA's Low Boom Flight Demonstrator Project and development lead on the X-59, the rollout is a major accomplishment. But it also means the next milestone is first flight and then supersonic flights after that. She proceeded to lay emphasis on their eyes being on the mission. With the rollout complete, the QSST team will shift to its next steps in preparation for first flight, including integrated systems testing, engine runs, and taxi testing for the X-59. The first flight of the supersonic aircraft had been anticipated to take place last year. However, in October, agency officials delayed the inaugural flight to 2024, citing several technical challenges identified over the course of 2023, including intermittent issues with some of the safety redundant computers. The QESST team will conduct several of the aircraft's flight tests at Skunk Works before transferring it to NASA's Armstrong Flight Research Center in Edwards, California, which will serve as its base of operations. Once the X-59 has flown over the half a dozen residential communities across the U.S., selected to offer a diverse mix of geographic and atmospheric conditions, NASA will engage with the communities on the ground to gauge their response to the noise. The goal is to confirm the theory that a 75 perceived loudness in decibels will be acceptable. The data gathered in this way will then be presented to the U.S. Federal Aviation Administration and international regulators. NASA believes that a change in regulations would open up the skies for a new generation of supersonic aircraft allowed to fly over routes that aren't permitted now, such as New York to Los Angeles, and cutting flight time roughly in half. However, nobody knows what those new aircraft will look like and who will build them because the X-59 is not a prototype but merely a technology demonstrator. Several companies are currently developing supersonic passenger aircraft and planes to fly them within a decade or less, including Hermes, Boom, and Spike. However, it's doubtful that any of them will be able to take advantage of the findings of the Quest ST program, which will likely inform the next generation of supersonic aircraft. Such aircraft, with the ability to fly anywhere, would democratize supersonic travel, marking a stark difference with Concorde's luxury status. Let's check out the features of the first supersonic fighter that was used commercially and compare it to X-59 design. The Concorde was a unique aircraft distinguished by its tailless design and narrow body accommodating 4 seats across, with space for 92 to 128 passengers. It featured a distinctive curved delta-shaped wing and a nose that could tilt downwards for improved visibility during landings. Powered by 4 Rolls-Royce/Snecma turbojet engines, equipped with adjustable air intakes, it had the capability for extra power during takeoff and supersonic flight. Constructed mainly from aluminum, it was the first passenger aircraft to use analog fly-by-wire controls, enabling it to reach speeds up to Mach 2.04 and sustain these speeds at an altitude of 60,000 feet. Air France and British Airways were the only airlines to operate the Concorde, with a combined fleet of 20 aircraft. Despite significantly reducing travel times, the loud sonic booms generated by supersonic flight restricted its operational routes mainly to overwater flights for safety reasons. In contrast, the X-59 design aims to overcome the noise barriers associated with supersonic flight over land. This next-generation aircraft focuses on noise reduction technologies to minimize the disruptive sonic booms. It represents a significant advancement in aerodynamic design and engineering, intended to make supersonic travel commercially viable over populated areas. While the Concorde faced competition from the Tupolev Tu-144, its operational history was marred by a tragic crash in 2000, which led to a temporary halt in commercial flights until safety improvements were implemented. Ultimately, the Concorde was retired in 2003 after 27 years of service, with most of its fleet preserved in museums worldwide. Looking forward, advancements in materials, engine design, and aerodynamics, as seen in projects like the X-59, offer promise for developing new supersonic aircraft that meet modern safety and environmental standards. These innovations aim to revive and advance the era of supersonic air travel, potentially offering faster and more efficient transportation options in the future. Other supersonic fighters left long-lasting effects, and we would explore 2 of these technologies, the XB-70 Valkyrie and the Spike S-152. The North American Aviation XB-70 Valkyrie is a retired prototype of the proposed B-70 nuclear-armed, deep-penetration supersonic strategic bomber intended for the United States Air Force Strategic Air Command. Designed by North American Aviation in the late 1950s to replace the B-52 Stratofortress and B-58 Hustler, the 6-engine delta-wing Valkyrie was capable of cruising for thousands of miles at speeds exceeding Mach 3 while flying at an altitude of 70,000 feet. At the anticipated speeds, the Valkyrie was expected to be nearly immune to interceptor aircraft, which were the primary defense against bombers at the time. The bomber would quickly pass over radar stations, exiting their range before controllers could deploy fighters for an interception. Its speed and altitude made it hard to detect on radar, and no Soviet interceptors or fighters could match its performance. However, the introduction of Soviet surface-to-air missiles in the late 1950s cast doubt on the B-70's near invulnerability. Consequently, the Air Force began flying missions at low altitudes to limit missile radar visibility due to terrain. In this low-level role, the bomber offered no significant advantage over the B-52 that it was intended to replace, while being more expensive and having a shorter range. Proposed alternative missions for the B-70 were limited in scope. The rise of intercontinental ballistic missiles in the late 1950s led to the perception that manned supersonic nuclear bombers were becoming obsolete. Eventually, the USAF abandoned efforts to produce the B-70, and the program was canceled in 1961. The focus shifted to research on the effects of long-duration, high-speed flight. Two prototype aircraft, designated XB-70As, were built for supersonic test flights from 1964 to 1969. In 1966, one prototype crashed after colliding with a smaller aircraft during a close formation flight. The surviving Valkyrie bomber is now housed at the National Museum of the United States Air Force near Dayton, Ohio. Aside from the shortcomings of the Valkyrie, let's check out some of its designs. This aircraft was a high-altitude bomber that could fly at Mach 3 with 6 engines. Harrison Storms designed the aircraft with a canard surface and a delta wing, mainly using stainless steel, honeycomb panels, and titanium. The XB-70 incorporated supersonic technologies from the Mach 3 SM-64 Navajo and a modified version of its inertial guidance system. This supersonic bomber utilized compression lift, which came from a shock wave created by the engine intake splitter's leading edge below the wing's apex. At Mach 3, this shock wave bends back about 65 degrees, creating a pressure zone that provides additional lift. Compression lift accounted for 5% of the total lift. The wing's leading edge had a camber to enhance handling at subsonic speeds and reduce drag at supersonic speeds. The wingtips could pivot downward by 65 degrees, improving stability and shifting the center of pressure to a better position at high speeds. This also reflected the shock wave from the intake splitter off the wingtips, adding more compression lift. To improve the pilot's view during low-speed flight and on the ground, the Valkyrie had an outer windshield and ramp that could be lowered. When raised, the ramp streamlined the aircraft's front. The windshield was kept clear of rain and ice by using hot air from the engines. The lower front section had a radar bay, and production models were to include a refueled yielding receptacle on the upper surface of the front fuselage. The XB-70 had 6 General Electric YJ-93GE3 turbojet engines, using specially formulated JP6 jet fuel. These engines produced 28,000 pounds of thrust with afterburner and 19,900 pounds without it. The Valkyrie used fuel for cooling, circulating it through heat exchangers before it reached the engines. To prevent auto-ignition, nitrogen was injected into the fuel during refueling, and the fuel pressurization and inerting system vaporized liquid nitrogen to fill the fuel tank vent space and maintain pressure. Now let's talk about the Spike, something more relatable with the X-59 and the retired Concorde. The Spike S-512 is an innovative supersonic business jet designed by Spike Aerospace, an aerospace company based in Boston, Massachusetts. Unlike traditional jets, this aircraft will not have windows for passengers. Instead, it will be equipped with advanced cameras that capture real-time external views, which will be displayed on thin, curved screens lining the interior walls of the fuselage, providing passengers with a continuous panoramic view of the skies. Spike Aerospace initially planned to promote their cutting-edge project at the 2014 EAA AirVenture Oshkosh Air Show, with the goal of launching the plane by December 2018. By January 2017, the company had planned to test a subsonic scale prototype during the summer to demonstrate the aircraft's low-speed aerodynamic flight characteristics. Following this, they intended to develop a series of larger prototypes and a supersonic demonstrator by the end of 2018, with the ultimate aim of certifying the S-512 by 2023. By spring 2018, Spike Aerospace was exploring the possibility of a larger variant, seating 40 to 50 passengers, targeting the 13 million passengers projected to be interested in supersonic transport by 2025. Despite initial plans, by September 2018, Spike anticipated the first flight of the supersonic aircraft to occur by early 2021, with deliveries starting in 2023. However, as of June 2021, the company was still focused on developing an 18-seat version of the aircraft. The Spike S-12 is designed with a length of 122 feet, which is about 37 meters, and a wingspan of 58 feet. The aircraft's empty weight is approximately 47,000 pounds, about 21,000 kilograms, and it has a maximum takeoff weight of 115,000 pounds. One impressive aspect is that it features a fuel capacity of 56,000 pounds and is powered by 2 engines, each providing a thrust of 20,000 pounds. In terms of performance, the Spike S512 can reach a maximum speed of Mach 1.8, equivalent to 1,033 knots, with a cruising speed of Mach 1.6, or 918 knots. The aircraft also boasts a range of 6,200 nautical miles and a service ceiling of 50,000 feet. The Spike S512 represents a major achievement in supersonic travel, and with a demonstrator like the X-59, more commercial supersonic aircraft would be built, which promises to drastically reduce travel times while offering a sleek, technologically advanced flying experience for business and private jet travelers. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.